Okay, starting into lesson 6.4. 6.4 is about rational exponents. Okay, big pop quiz here. Do you remember the word rational? Yeah. What does rational mean? You remember?
I mean, it's like 0 to infinity, but it has to be positive.
No.
But it can't be a square root.
Okay. So it can be positive or negative. It can be some square roots.
It can't be like pi.
Okay, it can't be pi.
It has, yeah.
Because pi is the other one. Pi is not rational. Pi is irrational.
It has to be able to go into a fraction.
Has to be able to go into a fraction is the official definition. Okay? Something that's rational can be expressed as a fraction. Pi, big, long, messy decimal. Big, long, messy decimals? No. Okay? You said some square roots. If I say, okay, square root of 5, what is the square root of 5? Some big, long, messy decimal. That fits the irrational category. If I say square root of 9, you're like 3. Oh, and that could be 3 over 1. Okay. Not the point of the lesson of what's rational, but, so, rational was decided, anything that can be expressed as a fraction. What are we doing today? Rational exponents, which means what kind of exponents? Exponents that are fractions. That's what we're learning how to deal with. Is if you have an exponent that is a fraction, what does that mean? How do we compute that? Okay? And so, properties of radicals here. And that's the deal. Notice, we've been doing square roots lately, haven't we? Well, guess what? Square roots and rational exponents, so fraction exponents, they connect. And that's what we need to know. X to the 1 over n is equal to the nth root of x. For instance, okay, you want a correlation here? For instance, if I say x to the 1/3, x to the 1/3 is the cube root of x. That's the connection that we're making here, is that when you have a fraction exponent, the denominator of the fraction tells us what root it is. So since this was x to the 1/3, it's the cube root of x. What would represent the square root of x? X to the 1/2, right? If you had something like x to the 1/2, that represents the square root of x, because what's the invisible number there? The little 2 that I just wrote in. That's no longer invisible, right? Okay, so that's part of this. The other part is, okay, that was just x to the 1 over n. So when the top of your fraction, your numerator is a 1, it just tells us, okay, what root? Square root, cube root. We can keep going on, right? Or what if it's x to the m over n? Okay, this is a memorization thing. You need to memorize. X to the m over n can be written one of two ways. We can write it as the nth root of x to the m, which is what you'll usually see me do. Or we could say the nth root of x raised to the m power. But what do you notice? The bottom of the fraction is still the root. The top of the fraction is the power or exponent. That location is always the same. It doesn't change. You need to know it. Okay? I just tend to try and remember that the denominator is the root, and then I go from there. Okay? Because we're used to seeing x to the 3rd, aren't we? We know what x to the 3rd is. That's x times x times x. We're not used to seeing x to the 1/3. And so that's the new part. For example, I think, what if I throw in, I'm looking for an example to throw in. What if I say the cube root of x to the 6th? Could you tell me what power that is? That is how that can be written as x to
6/3.
what power?
6/3.
6/3. Does that make sense? Because what did I say? The n, the denominator, is the root. So this 3 is your denominator. The power, so, is your numerator, your m. And so the cube root of x to the 6 is the same as saying x to the 6/3. Could you reduce that?
Maybe. X to the 2nd.
Yeah. 6 divided by 3 is 2, and it is x to the 2nd. Now, before you injured your elbow back there, was this what you were going to ask about, or? Okay.
Yeah. Okay, so would it be like the square root of x then?
No, because 2, if you're thinking that way, this is 2 over 1. So when you just have a whole number powered, just x squared is x times x. Don't go complicated there. Okay?
Can you divide 2 in the, like, in the square root? Like if you divide in with 3, so it's just the square root of x to the 2nd. Like,
But it wouldn't be, so you're saying if we divide the 6 and 3 here and leave it as a square root, at that point, because 6 divides by 3 and gets 2, there's no more square root left though.
oh, okay.
The square root is gone at that point because it just becomes x squared. Does that make sense?
Yeah.
Okay. So there are times you can do that. Do what you're thinking though. That's just not one of them.
Okay.
Okay. I'm going to tell you up front, some of what we're going to do in this lesson is going to be, just going back and forth and pretty easy to follow. Some of it's going to be a little more, okay, how do we work with the calculations, the computation? And it's going to be a little more, challenging. So let's start with example 1, though. As we look at this section, we're being asked to simplify the radical expression. Except it's given with exponents, isn't it? So 216 to the 1/3. That simplifies. And I don't want you to just grab the calculator and put it in. I want you to think, okay, what do I know about that 1/3 power? First of all, when I see a fraction, here's what I know. When I see a fraction, there's a radical. When I see a fraction in my exponent, there's a radical. Now, what's under the radical? What's under this root? 216, definitely, yes? The question is, in the fraction, where do the 1 and the 3 go?
The power of 3.
The denominator of 3 is my root. Now, when the numerator is 1, well, technically, where does that 1 go? Technically, it's a power. Do I have to write a power of 1, though? I don't. Now, here's the question. Can you go farther? Yeah, I don't even need my calculator because I can use my blue paper, can't I?
Yeah.
What do you notice in the cube root column about 216? Yeah. If you count down 2, 3, 4, 5, 6, the cube root of 16 is 6. Okay? Now, if you know how to type in a fraction exponent on your calculator, and there's a trick there depending on your calculator, you could technically type in 216 to the 1/3. However, then you're not knowing how to use the fraction exponent, and guess what? We're going to have some variables here eventually. So we need to know how to use them and what they mean. Okay? Okay, let's look at B. Unless there were questions on A. Okay, B. 7 to the 1/2 times 7 to the 1/2. Well, it's a couple different ways we can do this. Because you guys dislike fractions so much, well, what do you know? You see a fraction exponent. That means I'm going to write a what? A radical. And this is going to be a radical times a radical. 7 to the 1/2. What's under the radical is the 7. Where's that 2 go? The 2 tells me that this is a square root of 2, yes? And technically the 1 tells me it is a power. So what am I really saying here? Square root of 7 to the first. Square root of 7 to the first. What is the square root of 7 times the square root of 7? Did I hear 7 back there? Okay. Square root of 7 times the square root of 7 is 7. Now, if you don't like what we just said, then what are some of the rest of you saying? Square root of 7 times square root of 7 is square root of 49. But then, you know you need to go one step farther and say the square root of 49 is 7. I don't know if anyone thought this way, but you technically, since the bases were the same, you technically could have multiplied and added the exponents. 1/2 plus 1/2 is 1. That works. Okay, ready for C? 5 to the 1/4. Well, I see an exponent that's a fraction. Make that a little shorter. 5 to the 1/4. 5 goes under the radical. What's that denominator of 4 tell me? It's the 4th root. So the 4th root of 5 to the 1st, but we don't need the 1st, times, now I have 125 to the 1/4. So under my radical is 125. What root of 125 is it?
4.
Denominator 4, so it's the 4th root of 125. Can I take the 4th root of either of those? No. Neither of them are perfect 4th roots. Can I multiply them? Yeah, they're both 4th roots, and that's all that has to be true to multiply. So what is the 4th root of 5 times the 4th root of 125? 4th root of 625? Can we go any farther?
Yeah. 5.
Yeah.
Is this on your paper?
Yeah.
Yeah, the 4th root of 625 is 5. Always go as far as you can. Okay. Are we hitting the point where D is the easy one now?
Yeah.
64 to the 1/2. I'm just hearing 8. You guys skip the middleman here? I'm not against it. I'm not against it. I get it. But I'm still going to write down the middleman. Yeah. Because it's a fraction exponent, I'm going to write a radical. 64 under the radical, this denominator of 2 says it is a square root. And thus the reason you guys went ahead and told me the square root of 64 is 8. Now, if you could just jump to that, that's great. And for you calculator gurus that have to be able to do stuff on your calculator, which is not what I want to teach here, we know 1/2 is 0.5, don't we? Okay, 64 to the 0.5 power. Guess what your calculator is going to say? It's going to say 8. Okay, you can test these theories. I'm writing all over this board. Okay, E, 11 to the 1/2 times 11 to the 1/2 power. Okay, I agree with jumping to the end answer, but I'm going to take the baby steps here. 11 to the 1/2 means 11 under the radical, the 2 tells me it's the square root of 11. The other 11 to the 1/2 is also the square root of 11. The square root of 11 times the square root of 11 is? Okay. Square root of 121, which is also takes us right back to 11. Okay. So there are some shortcuts you can take, right? And that's fine. I'm fine with you guys taking some shortcuts here and there. Okay, F. What does 3 to the 1/2 mean? Okay, so it's going to go under the radical because it's a denominator of 2. It's a square root of 3. What's 12 to the 1/2 mean? Because there's a denominator of 2. It's the square root of 12. Square root of 3 times square root of 12. Okay, square root times the square root, you just multiply them as long as they're both square roots. And we have square root of 36. But the square root of 36 is 6. Getting the hang of it? It's not too bad, is it? At least this part, right? As I said, there's easy pieces and there's definitely more difficult pieces. Overall, my main goal is that you get the easy pieces. Now, some of this is going to be more difficult, but main goal, try and get you guys to get the easy pieces. Let's look at the back for a moment. The section we just did, not the back. It's the next section, sorry. Example 1, they gave you a number with fraction exponents, with rational exponents, right? Example 2. This time, they're still doing some of the same. It just kind of depends what they're giving you, but it's variables this time. Does it change because my base is a variable?
No.
It does not. So, what are each of the following in radical form? X to the 3/7. They want it in radical form, which means I'm going to be writing a radical. What goes under my radical? That, of course, is the base of x. Now, how do I write x to the 3/7? Where's my 3 go? Where's my 7 go? That's the, that's the big deal. What do you think, Justin?
It's the 7th root of x to the 3.
Okay. What did I say earlier? The number in the denominator, which is a 7, is your root. The number on top is your power. In the section above, all those numbers on top were 1s, weren't they? So I quit writing them. The 3, though, I need to write. I need to write that 3. So that right there would be a perfectly acceptable answer. This is how I would write it, honestly. 7th root of x to the 3rd. Because can I take the 7th root of x to the 3rd? No, in order to take a 7th root, I would need 7 x's. Do I have 7 x's? No. The other way that you might see this written is the 7th root of x raised to the 3rd with parentheses like that. There's nothing wrong with that. I just think that looks more confusing, personally. But there are times it's good to think about that. So both answers are good. I don't care what you write, but just so you know, both answers are good. I'm going to jump for a moment. What do I have left in time? Do I have?
Take a minute.
No. Okay. Well, I was going to jump, but never mind.
Just kidding.
Okay.
She pranked you.
I did. So, lesson 6.4. You can get started now. I don't know that you know how to do a whole bunch of it, but you can get started. Our plan will be to crank out the rest of the notes tomorrow, hopefully. I didn't get as far as I normally do because we did other stuff at the beginning. I will say, when we get to the back row, I don't usually do the example 5s. But my goal is to get through example 3 and example 4 on the back. Okay?